Hello everyone, this is Ernesto Manuel Cantone with STMicroelectronics, part of the MEMS and Sensors marketing team here in US, introducing the hands-on workshop Developing with Sensors Made Simple, curated by Andrea Vitali, Sensors lead in our application team. In this video, I'll introduce STMEMS sensors and the available development tools. After this, you will be able to watch the other videos at your own pace. They'll guide you step by step with software tool installation and configuration and through 7 different labs which touch several sensors and sample applications. At the end of the workshop, you'll have all the tools and necessary knowledge to start building your own application with sensors. Look around you, sensors are everywhere. They are in our phones, in our laptops, in our cars, in our homes, in our cities. Motion sensors, environmental sensors, microphones, optical sensors are all there to interface the physical world to the digital world, where the data coming from the sensors is used to create new business opportunities. We define the Internet of Things as a movement where familiar devices are evolving to become connected and smarter by leveraging the massive computing capacity of the cloud. This movement is affecting every industry and creating new ones, and driven by the broad availability of innovative sensors together with reliable wireless connectivity and affordable low-power embedded computers, its impact will be felt everywhere. Looking at the global semiconductor market value, we see that it has been steadily climbing up since the early 90s, and MEMS sensors have been a driver of this growth. The first MEMS wave was the mobile age. Smartphones became more and more popular, thanks to the evolution of mobile network technologies and the advent of social media. During this period, ST played a major role as the top supplier of MEMS sensors for consumer applications. Today, more than 10 years later, we are riding the next wave, started with the Internet of Things and its ramification that we see today in smart industry and smart driving applications. From our leading role, we have seen the market, our customers and partners changing and evolving, and with them their needs. In order to address these needs, both our sensors and the ecosystem around them have evolved. ST's sensors classification is well aligned with our 3 addressable market segments. Automotive, with products qualified according to ASIQ 100 standard, industrial, with extended temperature range and 10 years longevity commitment, and consumer, where ST pushes the technology envelope with advanced embedded feature, best-in-class accuracy and lowest power consumption in the industry. STMicroelectronics has the broadest portfolio in the industry with motion sensors, environmental sensors, optical sensors, microphones and microactuators. We have been working to develop sensors that meet the most demanding needs and shipped more than 19 billion devices up to date. We have been working in 5 main areas to address this evolution. First of all, we have been developing technologies that allow miniaturization and reliable manufacturing in very high volumes. New applications such as smart driving and augmented reality have been the driver to increase accuracy, precision, stability over time, and temperature for precise positioning and movement tracking. We have been working to integrate multiple sensing capabilities in the same device. For example, 10 years ago, an accelerometer and a gyroscope were 2 independent devices, while now they are one combo, and we have recently introduced motion and temperature sensing for asset tracking in the same device. There is a trend to push intelligence from the cloud to edge nodes. Inside these node systems, we are further distributing the intelligence, adding more and more smart functions into the sensors themselves to relieve the computing load of the host controller. Last but not least, power. Many of these devices need to be always on, always recording what is happening, and we have been pushing the boundaries with the lowest current consumption for motion sensor. ST offers then an entire ecosystem to support a developer's journey from first prototype to production. We start from the components. As we discussed, ST leads in sensors but also offer STM32 microcontrollers, power and connectivity devices. There are then evaluation boards, from a stackable boards approach to build an application adding specific functions to dedicated form factor boards such as the sensor tile.box. We then have a development ecosystem including IDEs, code generator, prototyping software, and pre-integrated sample application for specific verticals. All this is complemented by an online community and partners that can help to fill the gap between what ST can provide and our customer needs. Today, we will be using the STM32 Nucleo with the Sensors Expansion Board and STM32Cube IDE, the integrated development environment and automatic code generator for microcontrollers and sensors. Without the complete ecosystem, if one is starting from scratch a new project with sensors and microcontroller, it might be complicated. He or she will need to select components, build board, look at the datasheet, register configuration, write code. What we are going to demonstrate today is a combination of hardware and software tools that can simplify this workflow. Let's start with the hardware. Designing with Nucleo is a modular approach. We are going to use two boards. The first one is a Nucleo board which supports an STM32 microcontroller, the ultra-low power STM32L476 ARM Cortex-M4 with DSP and floating point unit at 80 MHz. The board includes an ST-Link in-circuit debugger and have various headers for added expansions. The second board we'll use and plug on top of the Nucleo is the X-Nucleo IKS01A3, the expansion board with the latest sensors from ST. On these we have LIS-DW12 ultra-low power accelerometer for motion sensing with embedded features and multiple low power and low noise modes. LSM6DSO, an inertial measurement unit, 3-axis accelerometer and 3-axis gyroscope combo with best-in-class power and noise performance embedding a programmable finite state machine. LPS22HH, high accuracy ambient pressure sensor. LIS2MDL, 3-axis magnetometer to sense magnetic field, including the Earth magnetic field for e-compass applications. STTS751, high accuracy contact temperature sensors, and for environmental sensing, HTS221 for ambient temperature and relative humidity. Let's take a look at the open development environment offered by ST. We have already discussed the foundation, which is the hardware, the STM32 Nucleo board and the companion expansion boards. On top of that, we have the STM32Cube toolset. From bottom to top, we have the hardware abstraction layer to decouple the application from the specific microcontrollers, the middleware libraries such as the file system or USB stack and many others. On the right side, one can find the software components for each expansion board, a specific hardware abstraction layer and corresponding middleware libraries. At the top, we can find sample application and function packs. Function packs are complex pre-integrated applications which use more than one expansion, for example, sensors expansion and Bluetooth expansion. Finally, we provide reference code for smartphone apps and examples on how to use cloud services. Our STM32 family of 32-bit ARM Cortex core-based microcontrollers and microprocessors are supported by a comprehensive set of software tools. Traditional integrated development environment with C and C++ compilers and debuggers from major third-party suppliers, as well as the embedded software libraries required to configure and initialize the MCU or MPU and monitor its behaviors in runtime. STM32Cube-MX is a graphical tool to generate the initialization C code for Cortex-M cores and generate the Linux device tree for Cortex-A cores. STM32Cube IDE is an integrated development environment. Based on open source solutions like Eclipse or the GNU C++ toolchain, this IDE includes compilation, reporting features, and advanced debug features. It also integrates the hardware and software initialization and code generation from STM32Cube-MX. STM32Cube Monitor data visualization tools enable to monitor and diagnose STM32 applications at runtime. STM32Cube Programmer provides an easy-to-use and efficient environment for reading, writing, and verifying device memory through both the debug interface, JTAG and SWD, and the bootloader interface, UART or USB. Xcube MEMS 1, the STM32 ODE expansion software that we're going to use today, is compatible with a number of IDEs including IAR, Keil, and STM32Cube IDE. In this workshop, we'll use the free of charge STM32Cube IDE. Let's get those boards out of the blister and ready to be programmed. I hope you'll enjoy this training and successfully complete all the labs and experience firsthand how simple it is to add ST MEMS sensors to your embedded design. Let's get to work!